Okay, let's remind ourselves of an old strategy for solving equations. If your equation has one written copy of the variable x, locate where x is, and undo the last operation applied to x. So for example, solve 3x minus 1 equals 15. So there's one x written, it's right next to the 3, and you'll notice that whatever x is, it gets multiplied by 3 due to order of operations, and then that result, whatever number that is, we end up subtracting 1 from it. So we should undo the last operation, which was a minus 1. To undo a minus 1, we should add 1 to both sides, right? So we'll undo that subtract 1, adding 1 to both sides. And here, let's do this thing. Let's be a little, this might be a little excessive in terms of the amount of writing, but let's be very clear about where there should be parentheses. Again, this is a lot to write. I get that. But it's good to be clear because while most of the time we won't get in trouble, we should at least be very clear about where the parentheses are so that we can then talk about in the future, oh, we just didn't draw these parentheses because we noticed that they're not necessary, right? But we should at least know that they're there. So how do we know that they're there if we don't at least write them in now? So we took the original left side of 3x minus 1, wrapped in parentheses, do a plus 1 on that, took the original right side of 15, wrapped it in parentheses, and put a plus 1 after that. So we've added 1 to both sides. Now, again, this is why it was excessive for this problem, but for some other problem, it won't be excessive. It will be very necessary. Here, just where the parentheses are located, we don't end up changing the meaning just by getting rid of the parentheses. Okay, the order of operations would say everything's just fine. So we'll have 3x minus 1 plus 1 equals 16. And then we can take care of the minus 1 plus 1. That will simplify to a plus 0. We don't need to write that. We have 3 times x equals 16. We should divide both sides by 3. Again, here there's actually parentheses around the 3x and around the 16. That is, the numerators of both fractions should be wrapped in parentheses, but here there's the numerator of the entire numerator of any fraction is technically in its own hidden set of parentheses, so we just didn't draw them. And then on the left side, 3x over 3, there's a 3 on top and bottom. Those are both factors that will cancel. In the denominator, I know it doesn't look like a factor, but that 3 is really thought of as a 3 times 1. So the left side will be x over 1, which we just call x. And the right side, nothing cancels, 16 over 3, so that's just 16 over 3. X equals 16 over 3. Okay, and down at the bottom, there's that box that again clarifies that in 3x over 3, in fact, the 3's cancel because, and it's here we are going through the detail of the work, showing that the 3 really truly is a factor of the top and bottom just by rethinking of the denominator as 3 times 1. So you end up with x over 1, which is really just x. Okay, just reminders about presenting work. Ensure that each line is an equation. You'll notice that there's an equal sign in the middle of the step. Sometimes due to the work with expressions, people are really tempted to put an equal sign to the left of the second, third, and fourth lines here, but you'll find no equal sign in those locations. Okay, so for example, shown in this red box, you're seeing writing 3x minus 1 equals 15, and then on the next line, writing equals 3x equals 16 is incorrect. What's going on here is I would read this and say 3x minus 1, you're saying that that's equal to 3x, but 3x minus 1 is not equal to 3x. I mean, in fact, 3x minus 1 is 1 unit smaller than 3x is. Right? So that's what this equals in front of the 3x would suggest. Please don't use an equal sign to mean the next step is. Certainly for expressions, that equal sign feels like the next step is. But that's just a coincidence. Equals should mean equals. And 3x minus 1 is just not equal to 3x. So the equal sign in equations really just belongs in the middle of each line of your equation work. So each line below, you write a new equation based off the previous equation. Right? So an equation turns into an equation. Okay, say you have the equation 2x plus 1 equals 10, and you want to multiply both sides by 3. I'll let you know that it's very common for people to try to write 3 times quantity 2x plus 1 equals 10 times 3, and have 6x plus 3 equals 30. And in the original equation, 2x plus 1 equals 10, this is sort of hidden because people take this times by 3 on both sides and write on top of it. Let me step back and say what I mean. There's this equation written, which should kind of, I think it's good to practice this principle of were already done. So as the slide title says, try to avoid writing on top of a previous equation. If that equation is good and done, like in this case it's the equation given, don't write on top of it. Write a copy of it as much as this may seem repetitive, and then write on top of it what you need to, because people get themselves confused, right? So taking this, writing that times 3 on both sides, there's technically nothing wrong, but writing on top of an equation that's already complete will make it hard to backtrack, and people often make some unintended errors doing things like this. So instead of writing on top of the previous equation, just write a new line, new equation one line below. So I know it's a little extra writing, but forming that good habit now will be super helpful for some of the types of things we're going to be looking at, right? So the idea is when one line is done, it's done because you say, hey, I wrote down an equation. There's a complete thought. The equation that I just wrote looks different than the previous line's equation, but even if it looks different, they're equivalent equations, right? So then move on and say, okay, I want to do something, but don't write on top of that equation. It gets really messy. So please also note this principle that an equation is truly a statement of balance. So if you start from 2x plus 8 equals 12, you really have to write, when you multiply by 2 on both sides, the multiplication dots here aren't so much the thing that's required, but parentheses are truly required. They're always there, and around the 12 maybe they're not all that necessary, right? But here 2x plus 8, if that's not in parentheses, something's going to be off in the meaning due to the order of operations. When you start with 2x plus 8 equals 12 and you decide to add 2 to both sides, yeah, there's technically parentheses, but those parentheses can be dropped to just have 2x plus 8 plus 2 equals 12 plus 2, no parentheses. For multiplication, dropping parentheses would result in this text shown in red: 2 times 2x plus 8 equals 2 times 12. Now the right side is fine, 2 times 12, that's fine. But you'll notice here on the left side, 2 times 2x would happen before plus 8 would. But it really should be 2x plus 8, that entire thing, that's its own concept. That should be protected in parentheses as shown in the first item here. And then that result should be multiplied by 2. So yeah, here it is, right? 2 times 2x plus 8 is due to order of operations 2 times 2x in parentheses plus 8, and not 2 times quantity 2x plus 8. Right? So think of an equation as representing items on one of those balances, like a physical balance I'm thinking of that has like 2 plates, and does the balance tilt or not? So think of it like this: 2x plus 8 equals 12. The 12 on the right side represents 12 individual weights that are each 1 gram apiece. Okay, the 2x plus 8, let's say that represents there's 2 mystery weights, the mystery because of the x, so 2 times x, so 2 of those, and then there's 8 additional 1 gram blocks. Right, so here's the picture that I have in mind. Right, so this is my attempt to draw one of those balances, at least a real basic one, sort of like a seesaw, teeter-totter here. So these dots represent individual 1 gram weights, and there's 12 of them on the right side, and there's 8 of those dots on the left side with 2 mystery weights. So these 2 orange cartons that we don't know the weight of, but hey, everything here is all balanced, right? It's not tilted one way or the other. And then if you do 2 times a quantity, that should just double what's in on the contents of the plates on each side. But how is that going to occur? How are we going to have a total of 4 of these orange cartons, and how are we going to have a total of not just 8 but now 16 of these 1 gram pieces on the left side? It really would need to be 2 times and then in parentheses 2x plus 8. Without the parentheses, this would just be 2 times 2x, then take a breath, then plus 8. And so that would mean there should only be 8 dots over on the left side. But we know we need 16 for this to balance, right? There should visually be a doubling effect here. And the only way to achieve that is by drawing these parentheses. This is going to force us to distribute the 2 in the next step.